So on number 12, we start where we're wanting milligrams per dose. So we know that we can give 3 milligrams for each kilogram that this child weighs. We have our weight in pounds, so we have to have a conversion in here. 1 kilogram is 2.2 pounds, and this is a pound sign, so we know that's 2.2 pounds. Our child weighs 38 pounds. That's given usually in 24 hours is what our order reads, but we're going to give it every 12 hours. So we have 2 doses. You could also just have it divided by 2 on the bottom 2, put 2 doses. But this way we know that we're going to give it every 12 hours, and that equals 2 doses. So when we do the math, we come out with 1368 over 52.8. So when we calculate that, it comes out to be 25.9 milligrams per dose. So that's our answer on that one. Okay, number 13. We're wanting to know the percent of weight loss that this baby has had. So it weighed 8 pounds 3 ounces at birth. So we want to change the 8 pounds 3 ounces to just ounces. So we have 131 ounces that the baby weighed at birth. The baby then weighed 7 pounds 12 ounces. And that is 124 ounces. So our difference, what the baby has lost, is 7 ounces. So this is the difference, and we want to divide that 7 divided by 131. So this comes out to 0.053, and it's per cent, so we're taking that times 100. That's what per cent 100 means. So the amount of weight that the baby has lost is 5.3%. So take the beginning weight, the weight that you have, the difference, and divide the difference by the beginning weight, and you'll come up with the percent every time. Okay, number 14, pretty straightforward. We just have to read the order there. The sliding scale says that the patient's blood glucose is 289. So we read it there, and it says give 6 units of insulin. That one's pretty straightforward. Number 15. We have a heparin drip going here. We want to know the units per hour that this patient's receiving. Our pump is running at 18 mils per hour. We know that we have 25,000 units in 250 mils of fluid, and it's going at 18 mils per hour. And when you do the math there, it comes out to 1,800 units per hour is what our patient's receiving. Okay, number 16. On this one, we're wanting to know milliliters per hour. So we start with 100 milliliters that has 1 gram in it. And we have to have a conversion, so our 1 gram is 1,000 milligrams. We're giving 25 milligrams per hour. Again, you can cross these out. 0, 0, 2 zeros up there, 2 down there. So you have 25 divided by 10. So this comes out to 2.5 milliliters per hour. Okay. All right, this next one, number 17, is a little more complicated. When you look at that, the first part of it, you see that our drip is running at 8 milliliters an hour, but we don't know what the units per hour is. So that's what we have to solve for first. We have to solve for the units per hour, and then once we do that, we read the order, we decrease it, or increase, I'm sorry. Oh, sorry. We decrease it by 3 units, and then we figure out what we set the pump at. So it's kind of a two-step process. So first of all, we have to figure the units per hour. And you guys, we always have to write out units because it has the potential of being misread. So units per hour. We know that we have 250 units, and that's in 100 milliliters. And it's running at 8 milliliters per hour. So when we cross those out, we have our units, we have units left, and we have our hours left. So that comes out to 20. So our patient is getting 20 units per hour. So when we look at our order, it says if the blood sugar is less than 250, which it is, it's 229, then we decrease it by 3 units. So we want to subtract 3 units. And so we want this to run at 17 units per hour. Okay, so now we need to see what we have to set the pump at. The milliliters per hour is always the rate of the pump. So we start with our 100 mils of fluid that contains 250 units of insulin. We want the patient to have 17 units per hour. So you can see when we cross out the units, we're left with milliliters per hour. Which is 170 over 25, which comes out to be 6.8 mils per hour. That's what our patient's getting, or will be getting to receive 17 units per hour. Again, if it starts out in mils and then we're decreasing by units, you have to find out what the units are. Okay, number 18. On this one, we're wanting, again, to know what the milliliters per hour should be. And we know from our problem that we have 250 mils that contains 100 milligrams. We have 1 milligram equal to 1,000 micrograms. Our order's in micrograms, so we have to do a conversion. We want to give 22 micrograms per minute. We still need our problem in hours, so we know 60 minutes is equal to 1 hour. This is our conversion. And when we figure that out, it comes out to 3.3 milliliters per hour. When you multiply all across that, and divide. And remember too, you can go back and you can get rid of your zeros before you multiply. So there's that, and there's that, and that. So 3.3 milliliters per hour for number 18. Number 19. On this one, there's quite a few factors in here. So we want to know what rate we're going to set the pump at. So again, we always start with what we're solving for, our milliliters per hour when we're solving for the rate of our pump. Okay, so we need to start with milliliters to match our numerators. In that 250 milliliters, we have 400 milligrams. We're wanting to have a conversion here because our problem is in micrograms. So we have 1 milligram, that's 1,000 micrograms. That's our conversion. We're wanting to give 10 micrograms per kilogram. We have our weight in pounds, so we need another conversion. We have 1 kilogram, that's 2.2 pounds. We have 189 pounds is what our patient weighs. And we're going to give all this per minute. And again, we need it in hours, so we have to have a conversion there. 60 minutes is 1 hour. So when you multiply this all across, you come up with 28,350 over 880. You can get rid of those. Comes out to 32.21, which is 32.2 mils per hour. Round to the nearest tenth, always, unless it's a drop. Okay, number 20, fourth level only is what this problem is for. So if you're not fourth level, you're done with this review. Number 20. On this, we're wanting to solve for micrograms per kilogram per minute. So we want to put our micrograms up here and our kilograms per minute on the bottom. So we know that we're going to need kilograms and minutes on the bottom after we've solved our problem. So we don't have any micrograms in the problem itself. We have our values in milligrams. So we need a conversion right off the bat. So we have 1,000 micrograms. It's equal to 1 milligram. Then we have 500 milligrams that will be running at 250, that are in 250 milliliters of fluid. That's running at 15 milliliters per hour. We have 1 hour is 60 minutes because we're going to need minutes on the bottom. We already have our weight in kilograms, so we don't need a conversion there. And we know it goes on, excuse me, on the bottom because we need kilograms on the bottom. So we put the 64 kilograms there. So when we go through and cancel out our factors, we're left with micrograms per minute per kilogram. Okay, so when you figure all that out and do your math, it comes out to be 75,000 over 9,600. So again, you can get rid of those two zeros.